Compound interest is a very common application of exponential functions. And so we're going to be dealing with that a lot. So if there was one most important video this week, I would say this one is it. So let's take a look. And again, this week we're going to look at how we compute compound interest given everything that we need. Next week we're going to learn how to solve equations to say what was the rate or what was the time, etc. So previously, if you'll recall, we found simple interest, I equals PRT. And when we did that function, the I was interest. So we really didn't find the accumulated amount that was in our account. We would have had to take our original amount, our principal, and add the interest from here, PRT. And so looking at what I did, I essentially just took a P out of both of these terms. I factored out a P, and that left me with 1 here and just the RT left over. So if I ask you to find an accumulated amount for simple interest, this is the function that I will use. Now, obviously we're looking at exponential functions this week, and this is not an exponential function. But I want to be able to compare simple interest to interest compounded however many times per year to interest compounded continuously. So this is a function you'll need to know. So again, I've written that function here, or that formula here for you for simple interest, just so it's on the same page as the other two formulas that you will use. But now let's talk about compound interest and what it's all about. If I had this simple interest equation, and let's say I put $100 in, and let's say at the end of a year I got $5. So at the end of the first year I have $105. Well, on simple interest, the next year I'm going to earn that $5 because again it was just on the 100. So at the end of that year I'm going to have 110. Now if I have interest that is compounded, and this is the formula I'm going to use for most compound equations, whether it's daily, monthly, quarterly, yearly, etc. This is the function I'm going to use. But let's understand what compound interest is. Using this same idea, let's say I put in my $100 and I gained that $5. So, and this is, let's say it's annually, so once a year. So I got that 105 because I get $5 a year, but the next time I earn the interest on the 105. So when I earn that next month's interest, instead of earning it on the 100 and just getting the 5 again, which is 5% of 100, I get 5% of 105, which is 525. And so it's really close. It's not much different. Oops, this is 110 plus an extra quarter. But then the next month, you know, then I'd have it based on the 110.25, so I'd be earning more than 525. That's what compound interest is all about. So obviously it makes sense that the more we compound, the more we're going to earn. So this was compounded once a year. If I compounded twice a year, then it would be more. If I compounded 3 times a year, it would be more. If I compounded every single day, 365 times a year, it would be more. You get the idea. Then, oh, and let's look at that formula really quick. The difference here is that we're taking the rate, which happened here, we're dividing it by n, because n is the number of times that it's compounded. So if it's compounded daily, that's 365 would be n. Oops. 365 would be n. If it's compounded monthly, there's 12 months in a year. If it's compounded annually, obviously that's once a year. Weekly would be 52 times a year. So hopefully we're getting the idea. So n is going to change based on how many times we're compounding. And then notice the exponent is n times t, so n again is one of these values or something like that, and t is the number of years, because if I'm compounding daily for 2 years, obviously I need to take 365 times 2 to find the number of times that I'm compounding. The last one, remember we looked at that natural exponential function. The last one if it's compounded continuously. So we don't wait till the end of the year to put the $5 in. You just get that money right away, and then that money starts making more money for you right away. So obviously compounded continuously is the best. And here we're just going to use, again, that e function that we just looked at when we graphed a moment ago. And it's e to the rt, so we don't have to worry about n's here because it doesn't matter how many times it's compounded. It's compounded all of the time. That's why there is no n when we're looking at a compounded continuously equation. So let's look at how this is going to look at an example. So if you'll notice, I've written all of our equations out for us so we can do this without having to scroll back through our notes to find our formulas. So this again was simple. This is compounded. This is compounded continuously. So those are the three that we're going to use. And let's take a look at the values that I've given you. My first value is 20,000, and that's how much I'm investing, so that's P. So that is going to be P in all of my equations. And keep in mind that the A always means accumulated value, so that's how much you have at the end. The 3% is my rate, but remember that my rate will always be written as a decimal. So that's going to go here, and here, and here. And then time is 7 years, that's T. Keep in mind I haven't shown you what n is because n will change based on the question that we're doing. So when we get to that, I'll show you the n for that particular question. So my first one is simple interest. Simple interest is this guy. So to find my accumulated value, I'm going to take the 20,000 that I'm investing, and I'm going to take 1 plus my rate, 0.03, times my time, because essentially I'm earning 3% per year times the number of years, which is 7. So I get, and in fact, I know that I'm a stickler about showing work. When we're talking about interest, that is the one change. Because what I find happens is people try to show too much work, and when you show too much work, you end up giving me rounded answers. This one's not bad because I can actually write the full answer. If I take 1 plus 0.03 times 7, I get 1.21, and that's really easy. And then my final answer would be times 20,000. That would give me $24,200. So this one's okay if you want to show all of the steps. But when I get to my next one, compounded annually, first thing I'm going to do is say, what would n be? Because n will change for each compounded question. And if it's compounded annually, that means it's compounded once per year. So n would just be 1. So what I'm going to do, and again, I strongly encourage you to have a good calculator to do this. But what I'm going to do is I'm going to set it up like this. And this is this equation, because whenever it's not compounded continuously, this is my compounded interest equation. So A equals 20,000. I'm going to change that too because it came out funky. And then 1 plus my rate is 0.03, n is 1 time per year, my exponent is 1 times t, which is 7. And to be honest with you, I don't need you to show more work than that, because what ends up happening is people will take 1.03, which is what that inside of that parentheses turns into, and they'll take it to the 7th power, and this value is 1.229873865, etc. And what people will do is they'll put 0.123. Well, then if I take that times 20,000, then my answer is way off. So what I really want you to do is to just plug everything into your calculator just like that. 20,000 times 1.03 to the 7th is what it turns into. And you can put everything in the calculator just as it looks. That was just easy math for me to do in my head. And I end up with 24,597. And again, this is money, so I'm going to round to the nearest penny. 0.477 would be 0.48. So that's compounded annually. Notice the only thing I showed was the initial setup and the final answer, and that's how I would like you to do it when you're doing your assessment this week. Compounded quarterly, same idea as compounded annually, but quarterly means that's 4 times per year, every quarter. So n in this case is going to be 4. Again, all I'm going to do for work is I'm going to set it up. 20,000 is P. 1 plus my rate is 0.03 divided by 4 to the 4 times 7. And I don't have to do any more work than that. From here, I'm going to plug it in just as it looks into my calculator. 1 plus 0.03 divided by 4, close the parenthesis, take that. I'm just going to take it to the 28th power because I can take 4 times 7 in my head. And then I get 24,654.234, so that rounds to 0.23. And I want you to notice before we do that last one, just as I said before, this was simple interest. Notice it went up a little bit when I went to annually, and it went up a little bit more when I went to quarterly, and it should go up more when I go to continuously, because that's going to be continuously compounding, taking that money all of the time and just plugging it back into your equation or into your account and then earning money on that interest. So let's take a look at that one. Again, now we are moving on to this function. So in this function, I'm going to have A equals P, which is 20,000, just as before, and then E to the RT. R, the rate, is still 0.03, and time is 7. So again, I'm going to plug it in just like that. Don't get crazy. Use that E button in your calculator. Do not try to put 2.71, etc. I want you to actually, put in the E, because we want all of those decimals, and then 0.03 times 7, or you could just put the 0.21. And when I do all of that in my calculator, I get 24,673.56 rounded correctly. Again, notice it did go up, not a ton that time, but it did go up more than it did when I had it compounded quarterly. You might feel as though you have enough practice now that we did that whole last question together, but you're going to see this over and over till the end of the course. So it's really important that you understand how to find all of the different types of compound interest and simple interest. So try this question. When you're done, press play to see how you did. So again, I'm already at like a 13-minute video, so I'm going to try to make this a little bit faster. I've already done these in my calculator, but remember my P is going to be 15,000. My rate is going to be 0.025. Remember, we move it 2 places. T is 4. Compounded monthly, N is going to be 12 because it happens 12 times monthly. There's 12 months in a year. And compounded daily, N is going to be 365. So let's go ahead and work these out and see what we get. The first one, A equals 15,000, and then it's 1 plus 0.025 times 4, and I don't need to simplify it any more than that. I'm just going to plug it into my calculator and find 16,500. Compounded monthly, same idea, 15,000. Then I'm going to take 1 plus, my rate is 0.025. My N is 12 times per year. I'm going to take that to the 12 times 4, 12 times a year times 4 years. And when I do that, I get 16,575, rounded correctly 0.84 because it was 0.839. Compounded daily, it's going to look exactly like this one, except 12 is going to be 365. So I've got 15,000, 1 plus 0.025 divided by 365, and then to the, whoops, wrong, 365 times 4, and again, I don't need to simplify any more than that, and I get 16, let me write it down here so I'm not totally out of room. I get 16,577.51 rounded correctly. And last but not least, certainly not least because it's compounded continuously, I would get 15,000 and then e to the r 0.025 times t, which is 4. And when I do all of that in my calculator, I get really close to my last answer, 16,577. This one's 0.56. So really, really close on those two. Again, because daily and continuously are so close together, this one I earned myself another nickel. So yay me. Keep in mind that I may not give you the same rate for each account when you're doing this on an assessment. So make sure you're reading very carefully.